With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. Let us try to solve the given problem. So the given problem is simply an assertion and reason type problem, and the assertion states in a diamagnetic substance each atom has a non-zero dipole moment, but due to thermal agitation the individual dipoles remains randomly oriented, and therefore the net dipole moment in any finite volume of the substance remains zero. So the first thing that we have to check in the assertion that for a diamagnetic substance, each atom has some non-zero dipole moment. We will check this. And then the reason says that on increasing the temperature, right, if we increase the temperature, the magnetism inside a permanent magnet increases. So we will check the reason also. Let us now try to analyze the assertion and reason one by one. So first of all, this assertion is false. Why? Because for a paramagnetic substance, not for a diamagnetic substance, for a paramagnetic substance. So for a paramagnetic substance, each atom has a net dipole moment m, right? Each individual atom has a net dipole moment m. Not for a diamagnetic substance. Let us now understand with the help of a diagram that why for a diamagnetic substance individual atoms does not have a net dipole moment. Now let us understand why an atom may have a magnetic moment, and let us understand what happens in a diamagnetic substance. So let us take an atom of a diamagnetic substance, right? We are taking an atom of a. So what happens in a diamagnetic substance is that there are paired electrons in a diamagnetic substance, right? So in a diamagnetic substance, what happens is that electrons are paired, right? Almost all the electrons are simply paired. Now, the magnetic dipole moment of electron is simply due to its orbital motion, because due to the spin motion, the magnetic moment simply is very small and it is neglected. Due to the orbital motion, we take the magnetic moment. Now, you see that in a diamagnetic substance, since all the electrons are paired, so one electron revolves in anti-clockwise direction and the other revolves in a clockwise direction. So what happens is that magnetic dipole moment due to this electron, let us say, will be in this direction, and magnetic moment due to this electron will be, say, in this direction. So what will happen, these two magnetic moments will simply cancel out. So you can see that in an atom of a diamagnetic substance, what happens is that net magnetic moment simply cancel out. So there is no net magnetic moment, right, for a diamagnetic substance. This is zero. So this assertion will be simply wrong. Now let us go to the reason. The reason says that on increasing the temperature, the magnetism inside the permanent magnet increases. Now this is also false. Why? This is also false. Why? Because what happens is that if we increase the temperature of a permanent magnet, two things happens. First, its strength decreases. Right, so if we increase the temperature, strength decreases. Now why strength actually decreases? Why? Because with the increase of temperature, right, what happens in a permanent magnet, there is this orientations of magnetic domains, right? We know that there are certain regions in a permanent magnets whose magnetic moments are aligned in a single direction. So what happens is that when we increase the temperature, then the strength decreases. Why? Due to the misalignments of magnetic domains. And also when we increase the temperature, strength decreases. Also the coercivity increases, right, which simply means that there are more chances that it will be very difficult to demagnetize the magnet. So that is the measure of its coercivity. We will require a more opposing magnetizing fields to remove the magnetism in a permanent magnet. So this statement is false, which will make this option correct, that both assertion and reasons are false. I hope you understood the entire explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.